We need more RAM. The PC's just not fast enough. So, does adding more RAM actually increase anything? Alright, so we've done this PC budget build for 2017, and we've already upgraded to Crossfire with 2 RX 460s. Now what we're going to do is we're going to add more RAM. It's going to be the G-Skill 2133 ddr3 that we're going to be putting in here. I already have 2x4 sticks in the PC right now. It runs in dual channel, so we're going to run 4 sticks of 4 gigabytes, totaling 16 gigs of RAM. And we're going to run some benchmarks. We're going to see if it does make a difference. I mean, is it going to be any different in gameplay? Probably not. Is my frames per second going to go up? Very likely. More than anything, when I'm rendering. That's when random access memory comes into play. Say if I wanted to render a video and then run over and make a thumbnail real fast while Adobe Premiere is rendering, will this get the job done? Will adding 8 more gigs of RAM make my PC run any faster when I have multiple applications open? Let's do it. Let's find out. Okay, so we're running the Resident Evil benchmark, and I can already tell that we are getting more frames per second. We're at 118 frames per second, averaging about 100, averaging 110 frames per second, which is it's up there. I mean, that's pretty dang good, that's for sure. Alright, I'm going to go ahead and skip this, or X out of that. That was just a quick look at what it could be. Okay, so now we're going to run the benchmark for Tomb Raider. Last time was 60 frames a second. I just think maybe that's just what this game is going to get. I don't think it's going to get any more. Maybe it's the refresh rate on the monitor. I'm not sure. But 60 frames a second seems to be what this Tomb Raider benchmark runs at. Alright, so the RAM actually, it's within the margin of error. I mean 0.2, so I mean not much of a difference, if any. Load times about the same. Alright, we're gonna run the OpenGL on Cinebench. Right here's our score from last time running Crossfire. Actually, I think we were a little higher. I didn't save that one. So, right here's us now. We were up here. I think we had we were in the 6th spot last time after running Crossfire. So I can already see we're a couple frames a second higher. Not too many. It's actually about the same. So we're in within the margin of error. Not much difference. I think the real test is going to be the rendering part of it more than the frames per second. Alright, so I mean, it put us right up there in the top. 74.71 frames per second. Let's go ahead and run this multi-threaded, multi-core rendering. This is where the RAM should have any difference. This is where it should make a difference. So this is us before, 4.4 gigahertz. We scored a 71.66. So if we beat that, the RAM definitely made a difference. Almost finished here. As you can see, we're 1, 2, 3, 4, 5, 6, 7, 8. Alright, so we beat it. We went from a 619 to a 622. So not that much of a difference, really. Maybe I need to go in there and overclock this RAM some. Okay, I'm going to exit out of this. There it is. The RAM, 8 more gigs of RAM made a little bit of a difference, but not a whole lot. I think overclocking your processor and your RAM a little going to have a bigger effect on it. So, alright, that's it. Okay, so my thoughts on adding more RAM. So we went from 8 gigs of RAM to 16 gigs of RAM, and I seen a very minimal difference. There really wasn't that much. When it came down to actually rendering out videos, I mean, it was about 30 seconds to a minute difference. So the rendering videos, it definitely made a difference, and multitasking definitely made a difference. Say I was in Adobe Premiere and I was uploading, and while I was uploading or rendering out, I wanted to go over and make a thumbnail. Photoshop did run faster, did load up faster, and these programs are on a solid state drive, and I mean they are cloud-based programs, but it did make a difference. I mean, it was very, very minimal. I mean, you really couldn't notice. Now, if you were to get into overclocking the RAM, you would overclock your CPU and make sure everything's stable there before you would ever start with your RAM. But I mean, this again is an older platform. But again, this was a budget build that we upgraded until, you know, we pretty much hit the limit of where you should go with this platform. I mean, with the new i7s and now the very new i9s, the X299 chipset and the X399 chipset, I think that would probably be the route to go right now. I am considering going that route myself, but if you just wanted to game, I mean, and have, you know, you can render a 15. Chelsea.
Shut up.
You can render like a 15-minute video in about 4 or 5 minutes with this setup. So again, this is FX8370. It's 2 RX 460 Strix graphics cards. It's 16 gigs of G-Skill Ripjaws RAM, the X series, whatever, and I mean, that's the basic hardware for it. I mean, it's an Asus 970 Aurora gaming motherboard, and it does very well for itself. And I mean, we've done some benchmarks, and it has stayed right up there with, you know, some of the newer technology. But the single-threaded performance, it's just not there. And I mean, it's up to you. But again, this budget build was to show you what you could build for around $600. Right now, we're around the $700 to $800, you know, limit, and it's showing its age. But again, I think for the next 2 or 3 years, you'll be able to get your work done with no problem. You'll be able to run 60 to 100 frames a second on games, and it is what it is. But again, the RAM made very minimal difference, and it is worth doing if you want to save a couple minutes and you run multiple applications at the same time. But if you're not doing that, save your money, stash it away, save it for a better system. Thank you for watching. This is Dustin with Tech Lifeline, and I'll see you later.